Hello, this is Joshua for Frost Dragon Designs, and today I'd like to talk to you about my Quantum Cats hard enamel pin. This pin is part of my More Cats Doing Science collection. The More Cats Doing Science pin collection features more than 35 designs of cats doing science and science-adjacent activities. Now let's get into the design. I called this design Quantum Cats because the idea for this kind of sprung out of two physics terms that pop culture has latched onto. One of them being quantum entanglement, and the other one being string theory. So this pin design is, in my opinion, a humorous take on the idea of an artist hearing, quantum entanglement and string theory, not doing any research, and then being like, okay, it's going to be two cats that are entangled with string. Now, this is humorous and wrong on a number of levels. Now, I'm not a physicist or anything, but to my understanding, string theory and quantum entanglement have virtually nothing, if not absolutely nothing, to do with each other. String theory is it's a theoretical framework. It is a way of thinking about single-pointed particles. And you think of them as strings that vibrate in space-time instead of thinking them as discrete, particles. They're still an individual object, but you're thinking of them as strings that can connect instead of as just particles. Yeah, I don't get it either. But the important part is it is a theoretical framework. It's not something that's necessarily observable. It's a way of thinking about things to try and, unify the concepts of physics and, quantum forces like quantum gravity and other strong nuclear forces. Quantum entanglement, on the other hand, is not a theoretical framework. It is an observable phenomenon. It is where two particles, quantum states, become intertwined, become one state, basically. Their polarity, their angle, their positioning, their momentum, spin. It's basically like these particles are synced up in every way you can think of. Now, what's cool about this is that they stay synced up even over very long distances. So if you have two entangled particles and you change the spin of one of them, it doesn't really seem to matter how far apart they are. You are affecting both of them. So this is really interesting from a standpoint of computing, from communications. It's functionally instantaneous, so this could be something extremely important for future technologies. Also, fun fact, Einstein referred to this as spooky action at a distance, implying that there was something supernatural going on. He said this facetiously, because basically the math at the time couldn't explain how this was possible. So anyway, thank you so much for your time. You have a great rest of your day. If you like this video, like and subscribe. I try to put out 1 or 2 videos a week. And I'd love to have you along for the next one. So thank you so much again. Have a great day.